Hello everyone, today we are going to start from our first video, age level chemistry, chapter number 1, moles and equations. Moles and equations related to moles. This topic is basically very, students consider this topic very difficult, but actually it is very not that much lengthy, and basically it is very simple topic. So moles is basically a unit of measure, a unit of measurement. Okay, the same like that we use for mass, we use gram. Okay, for time we use second, for volume we use centimeter cube. Okay, for in same case mole is also the basic standard for measurement. Okay, and here we measure quantities of reacting masses. Okay, so the quantities of reacting masses during any chemical reaction. Okay, so chemical reaction, when we are doing any chemical reaction, so we have to know the mass or the amount of reactants and products. For this purpose, in order to understand the or in order to understand and evaluate the masses on the or the weights on the reactant and product side, we have to understand the moles. So well, basically moles, when we are talking about mole, it is we can calculate them from three perspective. Okay, from three perspective we calculate moles from three perspective. Number one perspective is that moles in terms of quantity. Okay, second one is moles in terms of weight or mass. Okay, and third one is moles in terms of volume. Okay, now keep in mind that in terms of quantity, moles we consider moles in terms of quantity, and we take a specific number, and we consider that number as a standard unit. Okay, we take a specific number and consider that number as a standard unit for calculating amounts on the reactant and product side, and that specific number is called Avogadro number. Okay, in terms of weight or mass, keep in mind that in chemistry we take usually weight and mass as equal in chemistry. Okay, and volume, basically this moles, when we calculate moles in terms of volume, we have to keep in mind that volume, we usually use the volume, the unit of volume is basically used for liquids or solutions, and we also use volume for measuring the amount of gases. Okay, so this is how moles are being calculated. Now coming towards the first part of the lesson, that moles in terms of moles in terms of quantity. Okay, as I told you that this quantity, which is a specific unit. Okay, specific unit or specific amount or specific number. Okay, is taken as a standard or is taken as a reference. And with this reference number, we measure all other amounts of the substance. Okay, this specific number is 6.02 into 10 raised to power 23, and we call this number as Avogadro number. It is called Avogadro's number by the scientist who first introduced this. So Avogadro's number is this number. Okay, and we usually call we can consider this as a dozen. Okay, why dozen? Because for example, we say that in 1 dozen, 1 dozen of apples, it means 12 apples. Okay, but we cannot count items or molecules because they are so small. So we have to give them a very large value. This value is called 6.02 into 10 raised to power 23. Now, the formula for calculating is that number of mole is equal to any given quantity divided by Avogadro's number. Or we can calculate that Avogadro's number is equal to number of quantity divided by n. Is that clear? Or quantity is equal to Avogadro's number multiplied by number of moles. This n represents number of moles. Okay, so from one equation we find basically 3 equations. And now I will solve problems that how you can calculate number of atoms. So this 6.02 into 10 raised to power 23, basically it not only represents atoms, molecules, it also represents ions, charges. So it is basically refer to the particle. That particle may be in any form. That particle may be in the form of atoms, molecules, compounds, ions, charges, whatever the case may be. Okay. So now inside your workbook on page number 6, there is a question number 2, part B. How many oxygen atoms are there in 0.011 gram of carbon dioxide? Avogadro number is given for you. You have to find the number of atoms in 0.011 gram of carbon dioxide. So the solution is that definitely first of all you have to find the moles of carbon dioxide. For this we know that what is the formula for moles? We know that it is equal to weight divided by molecular mass. So weight of the substance is given, that is 0.011 gram divided by molecular mass of carbon dioxide, which is approximately 44 gram. After dividing this value, divided by 44, it comes out to be 2.5 into 10 raised to power minus 5. We will see if you see the carbon dioxide molecule, it consists of 2 atoms of oxygen. So what will we do? We have to multiply this value with 2. So 2.5 multiplied by 10 raised to power minus 5 multiplied by 2. So this will become 5 into 10 raised to power minus 5 minus 5 minus 5. Okay. Now if we going to find the value number of oxygen atoms is equal to 5 multiplied by 10 raised to power minus 5 multiplied by Avogadro's number. Avogadro's number is equal to 6.022 into 10 raised to power 23. So multiplying these values, 30.11 into 10 raised to power 18, almost 3.011 into 10 raised to power 19 atoms of oxygen. So this is how you can solve the question. The question is that how many nucleons are present on 1 mole of this lithium carbon atom. So lithium atom, how many nucleons are present? You see lithium atom, atomic number is 3. It means that they have 3 proton and 3 electron. Okay, so and their nucleons they have 4 nucleons. So we have 2 nucleons. Is equal to proton plus neutron. These are 3 plus 4 is equal to 7. So how many nucleons are present in 1 mole? So 1 mole of lithium atom consists of nucleons. We know that we have to multiply the quantity with the Avogadro's number. Okay, so here 7 multiplied by Na, 6.02 into 10 raised to power 23. So we will get, that is 7 multiplied by 6.0 42.154 into 10 raised to power 23. The final value will be 4.2 into 10 raised to power 23 nucleons. Okay, so this is how you can find the value. There is exam type questions may also be given for you, that for example 0.7 moles of magnesium ions are given as a sample. Part A, find the quantity of magnesium ions. Part B, find total number of proton, neutron, electron and total numbers. So first of all, I would like to remind you that that number of the moles is equal to number of the quantity of the substance divided by Avogadro number. And Avogadro number is also, we can find the Avogadro number as quantity divided by moles. In the same way, quantity of any substance is equal to moles multiplied by the Avogadro number. So starting from part A, quantity of magnesium ions, 0.7 also quantity of magnesium ion is given. Okay, is equal to number of moles multiplied by Avogadro number multiplied by number of moles, and that is number of moles are 0.7 into 10 raised to power 6.02 into 10 raised to power 23. So after multiplying these values, we will get 6.022 into 0.7. So almost 0.2 into 10 raised to power 23. Now part B of this question. First you have to find number of proton. We know that magnesium ion, the atomic number is 12. So it means that they have 12 protons. So what will we do? We will multiply 12 by whole quantity of the substance, that is 4.2 into 10 raised to power 23. Is that clear? So in the second part, this is that find number of electron. So number of electron is equal to, there are how many electron? Magnesium ion. This is the magnesium ion. Okay, so magnesium plus 2 charge. Magnesium plus 2 is, it means that magnesium has given 2 electron. Magnesium plus 2 ion. So it means that magnesium now it has only 10 electron. So number of electrons, this ion would have 10 into 4.2 multiplied by 10 raised to power 23. After calculating the values, proton value would be 5.04 into 10 raised to power 24, and that of electron would be 4.2 into 10 raised to power 24 quantity would be. So next, coming towards the value of quantity of neutron, and we know that neutron number is always the same, that is 12. So 12 is going to multiply with 4.2 into 10 raised to power 23, and it will be the same 5.04 into 10 raised to power 24. So these are the number of neutrons. In the second, most importantly, they ask that number of charge. Okay, very important. This type of questions do come in exams, so you have to find number of charge. If you look at magnesium, charge is +2. Okay, means the charge on magnesium is +2, and the value, the specific value, the constant value for charge is 1.6 into 10 raised to power 19. So charge 1.6 into 10 raised to power minus 19 coulomb is the value on charge. So what will we do? We will find the value of charge as 1.6 into 10 raised to power minus 19, and we know that the charge on magnesium is 2. Is that clear? If we multiply with this, plus multiplied by number of the substance. Number of substance was 4.2 as we calculated earlier. So 4.2 into 10 raised to power 23. So let's calculate this value. 2 multiplied by 1.6, 3.2 multiplied by 4.2, it will become 13.44. 23 minus 19, almost 4. It will become 4. So 1.344 into 10 raised to power 5 charge is present on this magnesium +2. So this is the value of charge, and this is how you can calculate the particles. Okay, so what you need to keep in mind is that quantities, if you want to find the quantity number of any substance, you just need to multiply the moles with Avogadro number, sometimes also write as LA. Okay, so this is the equation you have to keep in mind. Okay, and if you want to find the moles, you just need to divide both the values, that is that given amount of the substance divided by the standard value, that is Na. Is that clear? And Na is always specific, that is 6.022 into 10 raised to power 23. So such type of questions do come in A-level examination, and I hope that you've understood the lecture.